Welcome there, Mr. Sutton here, bringing you the AB Calculus 3.8 Extra Practice number 2 solutions on implicit differentiation. For number 5, getting y by itself would be a huge pain, so we're just going to do impdiff for this, going from left to right. Derivative of secant of x, that'll be secant x tan x. Derivative of tan of y, that's going to be secant squared of y times dy over dx. And then finally on the right side we've got 4x. Only a couple steps to go here. Let's subtract the secant tan over to the right side because it doesn't have a dy over dx, so it's out of the club. And then to get dy over dx by itself, I'll just divide by secant squared of y. Done. For number 4, trying to isolate y before differentiating is impossible here, so I'm going to use impdiff. Going from left to right, we've got 3x squared. Plus, we need a product rule here because we have two functions, x and y. So we have x and y, and the derivatives of those are 1 and dy over dx. Using my ribbon, I've got y plus x dy over dx. And then this negative 2y, that's going to be negative 2 dy over dx. Equals derivative of 1 is 0. All right, let's move the non-dy over dx stuff over to the right side. So I'm subtracting the 3x squared and the y. Now I can factor a dy over dx out of these two terms, leaving me with x minus 2 inside of parentheses. And then if I divide both sides by x minus 2, I've got my derivative. For this problem, we're trying to find the derivative of this curve. Since y looks awfully tough to isolate here, I'm going to use implicit differentiation. So going from left to right, we've got 2. And let's see, derivative of y is going to be dy over dx. Next, for xy squared, I need the product rule. So for my box and ribbon, I have factors of x and y squared. Derivatives are going to be 1, and this derivative is going to be 2y dy over dx. Multiplying it out with the ribbon, I've got plus y squared plus 2xy dy over dx. Next, on the right side, we've got derivative of x squared, which is 2x. And derivative of sine of y, this is going to be cosine of y times dy over dx, because again, we just took the derivative of y, which is an inner function. Now I need to get everything with the dy over dx on one side. We'll make it the left side. So I've got 2 dy over dx. That can stay on the left. So can 2xy dy over dx. I'm also going to move this cosine y dy over dx over to the left side by subtracting it. Now on the right side, I'm going to have equals, let's see here, the 2x can stay where it is. I have to subtract the y squared though. Now that I have only dy over dx terms on the left side, I can factor out a dy over dx. That'll leave me with 2 plus 2xy minus cosine of y inside of parentheses there. And now I can divide 2x minus y squared by all the stuff in this parentheses. And this is going to be my final answer for that derivative. On this problem, I want the derivative of this curve. I'm going to have to use implicit differentiation because I can't isolate y. So going from left to right, derivative of y squared, that's going to be 2y with a tail of dy over dx. And then for negative 2xy, I need the product rule. My factors are going to be negative 2x and y. And their derivatives will be negative 2 and dy over dx. Multiplying it out with the ribbon, I've got negative 2y minus 2x dy over dx, and that's going to equal the derivative of 16, which is 0. So I'm going to keep the 2y dy over dx and the negative 2x dy over dx on the left side so that I can factor out a dy over dx. I'm moving the 2y over to the right side, so I have to add that to get it over there. So factoring out that dy over dx on the left, I've got 2y minus 2x in a parentheses next to that, and then dividing everything, I've got 2y over 2y minus 2x. And I'm going to just divide by 2 everywhere. I'm just going to cancel out all those 2's to get y over y minus x. So that'll match my answer choice of C. On this problem, we want to know the derivative of this curve when x equals 1, negative 1 rather. So let's go ahead and take the derivative. And we're going to need impdiff for this. Y is going to be kind of tricky to isolate. I could do it, but I think impdiff is just going to be faster. So going from left to right, I have derivative of y, which is dy over dx. and that's going to equal, let's see, xy. I'm going to need a product rule there. So this is going to be box and ribbon time, factors of x and y, derivatives of 1, and since this is impdiff, dy over dx. Multiplying that out with the ribbon, I've got y, and this is going to be equals now because we're on the right side here, plus x times dy over dx. Derivative of x squared is just 2x. Derivative of 1 is 0, so we don't write it. Let me move stuff over to the left side now. I have dy over dx minus x dy over dx. And that's going to equal the y and the 2x that I'm leaving over on the right side. All right, on the left side, I can factor out a dy over dx. That leaves me with 1 minus x inside of parentheses. Dividing both sides by that, I have y plus 2x over 1 minus x. Now I have to evaluate this thing at the point -1 comma something. I have to figure out what the y value is, though, because I have a place to plug y in right here. So I'm going to plug -1 for x back into the original equation, and we're going to try to solve for y. So I've got y equals, this will be -y plus -1 squared plus 1. So let's see here. This is going to be -y. This is going to be plus 2 over here. So if I add a y on the left side, over to the left side, I've got 2y equals 2. So then y equals 1. So now we're going to evaluate this derivative at the point -1 comma 1 turns out to be the point we need. So in my numerator, I have the y value that we just found of 1, plus 2 times the x value of -1. Down below, I have 1 minus the x value of -1. Up top, this is going to be 1 minus 2, which is -1. Down below, 1 plus 1 is 2, so -1/2, which gives me choice B. For this problem, I need to find the derivative of this curve at the point 2 comma 1. Let's start by using implicit differentiation because y is kind of tough to isolate here. Not impossible, but just annoying. So let's see here. We've got derivative of x squared, which is 2x. xy is going to need the product rule. I've got a factor of x and y, and their derivatives are going to be 1 and dy over dx because this is impdiff. Multiplying that out with my ribbon, I've got y plus x dy over dx. Next, we have derivative of -3y, which is -3 dy over dx, using our chain rule there. That's all going to equal the derivative of 3, which is 0. All right, time to get the dy over dx stuff on the left and everything else on the right. So I have x dy over dx staying put, along with -3 dy over dx. Moving over to the right side by subtraction, we've got -2x and -y. Back on the left side, we can factor out a dy over dx, leaving us with x minus 3 inside the parentheses. And dividing by that, we've got -2x minus y over x minus 3, which I now have to plug 2 comma 1 into. All right, so doing that, in the numerator, we've got -2 times the x value 2, minus the y value we have of +1 rather, so -1. Down below we have x value of 2 minus 3. Numerator, this is -4 minus 1, so -5. And denominator was -1, so +5 then if we reduce that, giving us answer choice A.